Hello everyone, in this video we are going to learn about machine language. So in our previous video we have seen the basic computer introduction, and in that we have learned that machine can only understand the machine language which is written in the binary format in zeros and ones. So a program is a set of instructions arranged in the specific sequence to perform a specific task, and for that we are providing instructions. Computer converted that instruction into the machine readable form and execute the task. So we can say that the program written in any language must be translated in the binary form before executing by the computer. So for example, the ASCII value for letter A is 01000001. So when the value of A is stored in its memory, it will store in the form of this binary number, and when we displayed it, it is displayed as A on the screen. Yes, so when we are storing the data at that time, it will convert it into the binary form, and when we are requesting for read that data at that time, that binary information is converted into the human readable form. So as I said in our previous video, that we can write programs in a different languages, which is a binary code, which is called the machine language, octal or hexadecimal code. Second is a symbolic code, so that is called the assembly language program, and the last one is a high level programming language that we have that we are currently using to write any program. So these are the methods with that we can write a program for the computers. Now consider one binary program that is given in the table. In that, the first column in the table gives the address or the memory location of each instructions or the operand in the binary format, and the second column lists the instruction or the operands in the binary form. So let's assume that this is the memory location where our operand or our memory address will be stored. So this is 00000001 are the memory address, and here instruction code means, suppose we are telling the computer that add these two numbers. So for that, the instruction is something like this in the binary format. So by looking at this table, we can't recognize that what exactly the instruction is. Yes, it is very difficult to interpret, and to understand this we need to learn a different binary code. We need to remember the binary code for the instructions. So here the program is written is, so here this table indicates a program which adds the two numbers, and the hardware of computer will execute the instructions and perform the addition of two numbers. So just observing the instruction, it is difficult to understand what is to be achieved when this program is executed. The computer only understands the machine level language, so each instruction should be written in the binary form. Each instruction needs 16 bits. It can be writing an octal or a hexadecimal equivalents of binary code. The instruction code can be reduced to 4 or 4 digit using the hexadecimal equivalent of binary code. It means that here it needs 16 bits to store the instruction, and it is a little difficult. We can convert this format into the hexadecimal code. So it is something like this. This is a memory address, and this is the hexadecimal code for the instructions. So again, this is a better than this, but again confusing. Again we can't recognize easily that what actually the instruction is. Yes, and if we are using this method, then writing the program is a very difficult task. So next is a symbolic opcode representation of the program. Here memory address, then the instruction will be written in the symbolic form. In our previous lecture we have seen the different symbols to write the program. Yes, so we can write any instruction by using this symbols. So here this whole program is written to add the two numbers. So for that, the multiple instruction is something like this. Here LDA004 means load the operand into the accumulator. Then add 005 means add the second operand to accumulator. Third is STA006 means store sum at address 006. HLT means hold the computer. 0053 is a first operand. FFE9 is a second operand, and store the sum value at this 0006 memory location. So this is the complete instruction in the symbolic format. So with this symbolic representation we can write the programs. Again, program written with the symbolic codes are preferable and easier to handle, right? But if the operands are placed at the address following the instructions, and if program length is not known in advance, the address of the operand is not known until the end of the program is reached. So to solve this problem, hexadecimal address can be replaced by equivalent decimal numbers, since decimal numbers are more familiar than hexadecimal equivalents. So here we can write that symbolic representation into the assembly level program to add these two numbers. So this is a quite easy than the symbolic notation. Yes. So here org means origin. So this is the first instruction, and this is a compulsory for any program that we are writing with the assembly level language. It means origin of program is address O. Then load the operand from location A. Here O, A, B, C are the memory location. Here add operand from location B, then store sum into location C. Yes, so this is a quite easy than the symbolic or other representation. And at last, so this is the program that we all are familiar with. This is a program that is written in the high level language, and we can write this program with the simple English. So here this is a easiest way to write the programs to add the two numbers. So currently we are using this high level programming language to write the programs, and then assemblers and interpreters are converting these high level programs into the machine language program. So that's it. These are the different methods. By using this we can write a program. Thank you so much.